Lesson: AI techniques for intrusion detection systems. Artificial intelligence techniques have significantly advanced the capabilities of intrusion detection systems, transforming them from simple rule-based systems to sophisticated, adaptive, and proactive tools. IDS are crucial in identifying unauthorized access or deviations from normal behavior within a network. Traditional IDS, while effective to an extent, often fall short in dealing with the evolving and increasingly complex nature of cyber threats. AI brings a new dimension to IDS, enhancing their ability to detect anomalies, predict potential threats, and respond in real time. The integration of AI into IDS primarily leverages machine learning and deep learning techniques. Machine learning, a subset of AI, involves training algorithms to recognize patterns and make decisions based on data. In the context of IDS, ML algorithms are trained using historical data to identify what constitutes normal and abnormal behavior on a network. This training enables the IDS to detect anomalies that may signify an intrusion. Anomaly detection is a critical component of IDS, as it focuses on identifying deviations from established patterns. For example, an ML-based IDS can be trained on network traffic data to understand normal traffic patterns and subsequently detect unusual spikes in traffic that could indicate a distributed denial of service attack. One of the most common ML algorithms used in IDS is the support vector machine. SVMs are effective in binary classification problems where the goal is to distinguish between normal and malicious activities. They operate by finding the hyperplane that best separates the data into two classes. Research has shown that SVMs can achieve high detection accuracy and low false positive rates in IDS applications. However, the performance of SVMs heavily depends on the quality and quantity of the training data, making data pre-processing and feature selection crucial steps in the development of an ML-based IDS. Another powerful ML technique used in IDS is the random forest algorithm. Random forests are an ensemble learning method that constructs multiple decision trees during training and outputs the majority vote of the individual trees. This method is particularly effective for IDS because it can handle large datasets with high dimensionality and is robust against overfitting. Random forests have been successfully applied to detect various types of intrusions, including port scanning and brute force attacks. Deep learning, a more advanced subset of ML, has further revolutionized IDS by introducing neural networks capable of learning hierarchical representations of data. Convolutional neural networks and recurrent neural networks are two types of deep learning models that have shown promise in intrusion detection. CNNs, typically used for image processing, can be adapted to analyze network traffic by treating traffic data as images. This allows the CNN to capture spatial features of the data, which can be indicative of certain types of intrusions. On the other hand, RNNs, which are designed to handle sequential data, are well suited for analyzing time series data like network traffic logs. Long short-term memory networks, a variant of RNNs, are particularly effective in capturing long-term dependencies and have been used to detect anomalies in network traffic over extended periods. The effectiveness of AI techniques in IDS is not only theoretical, but also supported by substantial empirical evidence. For instance, a study by Schoen et al. Demonstrated that a deep learning-based IDS could achieve a detection accuracy of over 99% on the NSL-KDD dataset, a widely used benchmark in intrusion detection research. This level of accuracy is significantly higher than that of traditional rule-based IDS, which often struggle with high false positive rates and limited adaptability to new threats. In addition to detecting intrusions, AI techniques can also predict potential threats before they materialize. Predictive analytics, powered by AI, involves analyzing historical data to identify patterns that precede an intrusion. This proactive approach enables organizations to strengthen their defenses and mitigate risks before an attack occurs. For example, predictive models can analyze user behavior and network traffic to identify early warning signs of an insider threat, allowing security teams to take preemptive actions. However, the integration of AI into IDS is not without challenges. One of the primary concerns is the quality and availability of training data. IDS rely on large volumes of labeled data to train their models, but obtaining such data can be difficult due to privacy concerns and the need for continuous updates to reflect the latest threat landscape. Moreover, AI models are vulnerable to adversarial attacks, where attackers manipulate data inputs to deceive the IDS. This necessitates the development of robust AI models that can withstand such attacks and maintain their effectiveness in real-world scenarios. Despite these challenges, the future of AI in IDS is promising. The continuous advancements in AI research are likely to yield more sophisticated and resilient IDS. For example, the incorporation of unsupervised learning techniques can enable IDS to detect previously unseen threats without requiring labeled training data. Additionally, the development of explainable AI can enhance the transparency and interpretability of AI-based IDS, making it easier for security professionals to understand and trust the decisions made by these systems. Furthermore, the application of AI in IDS is not limited to large enterprises. Small and medium-sized businesses can also benefit from AI-enhanced security solutions. Cloud-based IDS powered by AI offer a scalable and cost-effective option for organizations with limited resources. These solutions provide real-time threat detection and response capabilities, ensuring that all organizations, regardless of size, can protect their digital assets from cyber threats. In conclusion, AI techniques have significantly enhanced the capabilities of intrusion detection systems, transforming them into powerful tools for identifying, predicting, and responding to cyber threats. Machine learning and deep learning algorithms, such as SVMs, random forests, CNNs, and RNNs, have demonstrated their effectiveness in detecting anomalies and predicting potential intrusions with high accuracy. Despite the challenges associated with data quality and adversarial attacks, the future of AI in IDS is optimistic, with ongoing research and development expected to yield even more sophisticated and resilient solutions. As the threat landscape continues to evolve, the integration of AI into IDS will remain a critical component of enhanced cybersecurity strategies.